Integrated circuit 12, digital circuit, programmable logic. Programmable logic is the purpose of having programmable logic is to reduce the number of gate or transistors, and second, simplify the logic design. So when you have some system design, it's make it a logic design. Do not worry about the circuit, and transfer this logic equation into programmable logic array. Programmable logic array is going to take care of large logic equation like x equals a, b, c, whatever. This complete logic equation you can just put in a programmable logic array. It's very simple to realize this equation. So the task of designing IC chip become more logic design, and the remaining process is software automation to produce the logic array programming. Then that will produce desired logic chip. Now the one often used is so-called open collector configuration. Open collector is this part is missing, the upper stage. The reason is you tie all the collector together and has a one pull-up register. And what's happened is all of them tied together at this knot becomes the NAND operation. So you can tie many gates together and NAND them together, right? So the way programmable logic typically is made is you have set of input, and you have a connection to each line, and this is OR is actually it can be NAND, right? So you can have inverter here, which is just transistor output stage. So it's invert the input. This logic equation has to be taken care of, this inversion, and most of the time it's used the emitter, and it's just indicate, see if emitter is connected or not connected to this line, and that's going to give the NAND, and that's inverted and becomes OR. Okay, so this is the programmable logic array, and if you do that for each chip, custom chip, this is a programmable logic array. If you make this connection here by fuse, and you can blow fuse from external power inside the chip, then it's become field programmable logic array. So you have a basic master logic array chip, and you program to blow fuse for each location on each chip. Then this becomes semi-custom chip. Okay, so that's a kind of design often used, and this is much more manageable because you have an equation. If there is a debugging necessary, you find out which part has to be corrected and remake the programmable logic array. You don't have to deal with the jungle of this logic design. Okay, so this is often used. Only disadvantage is it's because if you make a large array, it's going to be relatively slow. But it's controllable, because if you make this all logic component together, the worst case delay is what you have to deal with, and often it's not that easy to find worst case. You use a software to find worst case path for the worst case delay. Why this delay is important? Okay, any logic design, we use a state machine. State machine is, we have a clock from register to register. A register is a collection of flip-flop, and you have a state 0101 and go through the logic, and sometimes go to the different flip-flop, and is stored partially. Some of them go through the logic array and go back. Some of them go all the way to the second stage or third stage and go back. So come to think of it, the CPU has a set of register, and ALU, and you take two operand, operate and bring back to, this is like machine language, add register 1 and register 2 and bring it to register 3, or bring it to register 2, rewrite register 2. Okay, this is basically state machine. The CPU is large state machine, and the state machine, the state is expressed by the state machine diagram. You have a state S1 goes to S3, and S2, S4. This, the interaction transition of the state is called a state diagram. Okay, and the IC chip design for digital circuit become mostly making a state diagram and convert that into logic array and register. And logic array is created by software based on the logic equation. So design itself is like a logic, the state diagram and the logic equation. Here's an example, the traffic signal. This traffic signal usually change from green to amber, amber to red, red to green. But if you want to make it a little bit more logic in it to make it intelligent, you detect traffic amount, and if beyond a certain amount, you extend the green light, so time delay, state change happen. And the red is also, you detect something, and based on that amount, you extend the red light. So this is going to be the state diagram. And this state diagram, each state you assign the logic state. If it's a 4-bit, green is 0001, amber is 0010, and 0011. And here's a detection and if condition, right? Logic if condition. If above certain amount, it goes here, timer, and come back. So each time the if amount of traffic is large, then it's a green, stay as green, but you cannot make it green forever. So here's the inside has a timer, and if extended, say 3 times, then unconditionally go to amber. So that's a kind of logic state diagram, and change this to logic design and use logic array and flip-flops, and you make entire logic. Then you have a one chip semi-custom chip to control the traffic signal. Okay, so that's the way that IC chip is designed in the digital circuit. I hope you like it, and if you like it, subscribe.